Electric power is everywhere present in unlimited quantities and can drive the world's machinery without the need of coal, oil, gas, or any other fuel. This new power for the driving of the world's machinery will be derived from the energy which operates the universe, the cosmic energy.
With over 200 patents to his name, Tesla was well on his way to transmitting electric power without wires when he ran into trouble with J.P. Morgan and the financial interest of 1901. His ambitious Wardenclyffe project to magnify and transmit power to ships at sea and eventually to provide free electricity for the whole world was scuttled by Morgan, leaving Tesla penniless and disillusioned. The wealthy industrialist of the time knew that their vast plans to wire the world with copper from the mines they owned would be upset if they could no longer control the supply and means of delivery. Tesla's beliefs about developing technology in harmony with nature conflicted with the prevailing American attitude at the time that mankind was put on Earth to subdue and dominate nature. Little by little, Tesla was denounced as a crackpot and deleted from the historical record. At the time of his death in 1943, Tesla's truckloads of scientific papers were seized by U.S. government agencies. Who knows what ideas and remarkable devices our world could have inherited if only his genius was recognized. Victor Schauberger's vortex experiments during the 1930s resulted in an advanced understanding of how the spiraling motions inherent in all natural systems reverse the effects of entropy. By studying the properties of inwardly spiraling water, he created an implosion generator that concentrated electrical charge. Schauberger's ideas became widely known before World War II when he was coerced to work for the Nazis on exotic discs that resembled flying saucers, as well as his energy generator. In 1958, he traveled to the United States, where he was told he could manufacture his devices, but he was duped into signing over all of his rights, and none of his inventions were ever developed. Returning to Austria, he died a bitter and broken man. Benjamin Franklin is credited as being the inventor of the electrostatic motor back in the 1700s, but its power output was modest. The Wimshurst electrostatic generator is a high-voltage mechanism developed in the 1800s, which can be hand or self-started and will produce dramatic sparking while charging Leyden jars. Today, it's used in teaching about electricity, but its practical applications are considered inconsequential. A high-tech variation of the Wimshurst device is the Testatica, or Swiss ML converter. Developed by Paul Baumann of the Maternita community in Switzerland during the 70s, this free energy device is a marvel that has been in operation for more than 20 years, supplying electricity to the small, self-sufficient Christian community. Many technical experts have come away stumped by its excess output. However, because the community feels that the majority of mankind is not ready to be responsible for such unlimited energy, they're keeping the technology under wraps until such time the world is spiritually prepared. Other researchers, like Dr. Oleg Jefamenko, continue to pursue real-world applications for harnessing the electrostatic motor. Like the homopolar generator, the electrostatic motor is based on the dynamics of our Earth environment. As with wind and solar power, they offer real, sustainable alternatives that, with only modest gains in efficiency, could contribute to the replacement of our current dependence on fossil fuels. The force of inertia is known in mechanics, but until only recently, it had been considered too weak and difficult to harness for propulsion. According to some theorists, like Hal Puthoff, inertia, like gravity, is what occurs when we try to accelerate an object against the zero-point fluctuations in the vacuum. We run into resistance. Canadian inventor Roy Thornton has developed an inertial impulse propulsion engine which overcomes that resistance using centrifugal force. It pushes against nothing and emits no exhaust, but it's been calculated to be 20 times more efficient than a jet engine. Here, the Thornton inertial propulsion drive powers a canoe in a swimming pool. The motor, which is housed in a box, never contacts the water or air.
This is a standard.
Utah inventor Paul Pantone has developed what he calls the GEET fuel processor, a plasma generator similar to a super carburetor that actually appears to run on 80% water and is entirely non-polluting.
This device replaces the carburetor and exhaust and combines them as one unit, whereas this end of it acts as a miniature refinery, allowing the engine to run on everything from battery acid and water mixed to crude oil right out of the ground. This is Angola crude, a 39.5 gravity. The exhaust coming down goes around and comes out here at the far end. The center chamber draws some of the heat from the exhaust, plus this tube takes some of the exhaust gases, takes them up into the chamber and bubbles them down to the bottom. The bubbles, as it comes through the fuel, are brought up to the top of the chamber, picked up through a tube, and fed up the center of the exhaust pipe. While they're being fed up the exhaust pipe, they are in a vacuum, and there's a heat exchange which occurs. This process has been argued a few times to be either a plasma field, an electro field. We do know that it does have a slight radiation, which is not alpha, beta, or gamma, and we do have x-rays to show that whatever is coming from the unit does get affected different from stainless steel than the regular steel. Yep. When the temperature of the exhaust is the same as the air temperature going in from the air portion up here, normally 3% more oxygen coming out of the tailpipe than there is in the air we're breathing. And no carbon at all.
Carbon vanishes.
I wouldn't say vanishes, I would say transmuted into some other substance, a lighter element, because we have an abundance of lighter elements here that are not explained from down here. But during the heat process, there are molecular changes. After running this engine from 1983 until now, and many times we had it running 8.5 hours a day, we have never had to change the spark plug, change the oil, or clean it. We have taken the head off 3 times to inspect the inside of it, and it's been spotless.
What we have here is the Pantone GEET device fitted to a Ford 2300cc 4-cylinder engine. As you can see, we have a see-through container here which holds the fuel. As the engine is started, air is drawn in by vacuum through the fuel and bubbles the fuel, the vapors of which are drawn off here. They travel down this hose into our reaction chamber. They go up the reaction chamber and return back out here to be taken into the engine through this tube. This is our air filter, and this tube is connected to another valve, which are controlled by this linkage, operating the air intake and the fuel intake. This is the valve that controls the return air going through this tube into the bubbler. During the testing with the 2300cc Pinto, we have achieved efficiency up to and including 300% of normal. If this engine normally got 20 miles to the gallon on the highway, you'd now be looking at 60. Our load tests and whatnot have not been completed, but we feel very confident that there's not going to be a power problem
out there that wasn't.
David Porter of Galtech Semiconductors demonstrates his recently patented permanent magnet motor called the Carousel electric generator.
This is the latest version of the Carousel motor generator. It's a rotary version. Rotary inside. There's 18 separate sections, what we call a coil section in here. 18 make up the outer diameter. There's 6 coils here that we're using to drive the motor. At the top here we have an encoder which sends a pulse down to the electronics and basically lets the electronics know where the rotor, the rotating part here, is in relationship to the coils and tells the coils when to turn on and off. That's done by a specific index point that the encoder has that sets the relationship between the two. And the electronics down here in the box is basically a set of TTL logic counters. It counts the number of pulses from the encoder, and it turns the power on and off to different coils depending on where the rotor is at the time. We have also hooked up to this system a connection to the computer over here. What it gives us the opportunity to do is change the duty cycle on the system. We can change it from a pulse rate of 1 pulse per cycle up to 40 pulses per cycle, which would be 100% duty cycle. That is incorporated in, and what we do is change the pulse rate on the computer. It downloads the data to the electronics. When the index pulse comes around, which comes around once per revolution, it updates the data in the counters, and that's what changes the pulse rate on the system. Okay, we don't have an automatic start on the system right now. That's something that the Intel chip will do. We'll start it up at a pulse rate of approximately 13 pulses, which gives us a 16% duty cycle. It takes a while to spool up because, like I say, it works also as its own flywheel, so we build up the power gradually. The thing about this system is that everything floats on the magnetic field in there. You have very little internal friction. Once the system gets up to speed, it stabilizes at a certain RPM. Right now we're running at about a 30% duty cycle per channel. The speed is still coming up a little bit. Calculate the speed off of the scope here, and we're running about 1,850 RPM. This white and the green shows the 2 channels on the motor. The little spikes there are the amount of time that each channel is on, and the flat part at the bottom is the amount that it's off. So you can see how much is pulsing and how much time it's off and how much time it's on. One of the analogies we like to use is it's like if you pick someone up and take them across the street, you use a lot of energy. If you put them in a tire, once you get it started, all you got to do is tap it a little bit. And so you use a lot less energy to move the same load. And that's what we do. We build it up to a high speed, and then we just tap it with a little juice as it goes around. And we use the inertia built into the system to take it the rest of the way there. So we're using a high-speed pulse on the system. What we're doing is removing the energy from the magnet. The magnet has a specific life. They lose approximately 1% a year. So we're not actually trying to create energy from nothing. The system will not run forever. It's not perpetual motion. We use the amount of energy that is in the magnets Once that energy is used up, the magnets can be taken out, they can be recharged. All we're doing is maximizing the efficiency of the electromagnetic flux density that's there to the production of electrical output.
Troy Reed has been busy in his shop constructing rotating magnetic motors that he believes will soon revolutionize how we get around.
And it does work. This is a new prototype of the magnetic motor, and if I can explain a little bit about what you call a magnetic field. All magnets, the big old wooden prototype, has a system. As the motor went over, it had a tension to jerk over like that. If you take this motor here and you take your finger and rotate it, it doesn't have that jerking in it. So what I've done, I got rid of the crankshaft. I've got rid of the injectors, and the system in this motor here, as you crank this motor up, and like you do the other one, the motor will start running, and what I'll do, I'll energize it on this motor here. If you can see these amp gauges over here, this will come, when we get it up to about 150 volts, we'll unplug it and we'll turn the light on. If you turn this around where you can see this side here, all the working parts is behind this system here, operates from a little computer. Takes this 5 volts, it's 150 volts. What we're going to do, turn off all the switches, make sure there ain't nothing plugged into it. There's the plug. There's your 110 volts. Motor still running. You can operate this table plumb around. Still got energy running. Nothing tied up in the back of it. Nothing on the floor. Rotate it around, still running electricity. This is an automatic transmission car. There's not a whole lot of what you call junk, I would call, under cars. I've seen a lot of electric cars that had a lot of stuff in it. The only thing that this has a battery to run the radio, the blower. We've got 2 safety switches over here that can be mounted into an enclosed system, but we did this where you could see, where people can see this car with the technology. It's a safety switch system. This is a controller box, a Curtis control box. It cuts the amperage down. So with the amperage, here's what's real good about electric automobiles. All electric automobiles that has surge technology with this in it, they create heat. They've got to have a fan to blow this Curtis controller off because it gets hot. We don't want that to get hot. We want to stay that cold, because once it stays cold, you save on all the computer chips that's in this controller. So that means you can go farther, longer, and you won't have no problems.
But even simpler methods are being demonstrated through common ingenuity. Dennis Lee of Better World Technology has been struggling to pursue his dream of achieving energy independence for everyone on the planet. Held in prison for 2 years without ever being convicted of a crime, Lee mounts public demonstrations in major U.S. cities, lining up individual dealerships to market his devices. A controversial figure who some dismiss as a fraud and others see as legitimate, if outspoken, P.T. Barnum of free power to the people, Lee has assembled an impressive line of prototypes and processes, including those by other inventors like Yull Brown. Although he claims his machines are not utilizing zero-point energy because they draw heat from the surrounding air, his numerous devices supposedly achieve super efficiency rates by recycling excess energy through closed-loop systems.
I built the world's most efficient heat pump and developed it, and these are the evaporators for that heat pump right here. They're 8 feet high, 3 feet wide. Now, the refrigerant we put in here boils at 40 degrees below zero. Therefore, anytime, day or night, outside in a rainstorm or in a windstorm, a hailstorm or a snowstorm, or just out on a nice hot sunny day or in the middle of a cold night. As long as the refrigerant that's inside this panel is colder than whatever the air is out here or the phenomenon that's hitting this panel, then the heat from the air or the sun or the wind or the rain or the sleet or the snow will be transferred into the refrigerant on the other side, because it's the second law of thermodynamics. Hot goes to cold. So if this is the coldest thing outside, anything out there that touches it is going to give its heat to it. A little bit of heat goes a long way. That gas starts expanding like crazy, and as it expands, it then is drawn into the compressor, not through suction. I've got engineers and inventors that don't like to use the term suction, but through negative pressure. So as the compressor is creating this negative pressure, the gas is migrating to it. And so a compressor is a gas pump. It'll pump gas. And so the gas is being pumped by the compressor into the compressor, elevated in temperature. And even though if you touch this panel, it's ice cold to your hand, and if you touch the line going out of the panel, it's still ice cold to your hand. When it hits that compressor, compressor takes all the gas in this space, puts it in that space, elevates the pressure and the temperature. Going out of the compressor, do not touch that line whenever that thing is on, because it's 200 to 250 degrees hot. And so that's where we get the heat. All of the heat is transferred in here. We then use a compressor to take the relatively useless energy that we've got and elevate the temperature and pressure and make it very useful energy. Then that heat would be transferred later. This is a direct drive compressor. This direct drive compressor takes Freon from the panels, and it runs that because this direct drive is causing the pistons to go up and down. That gives us heat into the boiler. The boiler expands the other Freon back through that into a double-acting piston that's going back and forth. We're converting with mechanical apparatuses, we're converting that into shaft rotation. That shaft rotation turns this wheel. As this wheel turns, it causes the compressor to turn. As the compressor supplies the heat, it causes this wheel to turn. You might say these two wheels are powering each other. And by the way, once the Freon has taken the heat, it then made the power, it then goes up here. This is a condenser. We're sucking water out of the bottom of the tank, could be the well. And we're running the water through this pump right here that's also driven by this same drive mechanism, running the water into this condenser. It's the world's most efficient condenser at 100 degree delta T, 6 million BTUs. And as we're then running the water through, we're making the water hotter, but the water will also be being pumped. And as I do this, I'll show you the water being pumped. And then also, we're cooling down the Freon, which is going into this canister and is being pumped right back into the boiler by a little trombone pump that's running on the same cylinder. You ready to try it? Let's go ahead and try it. Let's turn it on, guys. Okay, if you're ready, Maestro, anytime you're ready. Okay. So it is pumping water from energy taken out of the air, and we'll light the lights too from excess energy. So the lights are being lit from excess energy from the air. They're pulsing. It wasn't set up to do that, so we don't have it stable, but we thought we'd just demonstrate the excess power that we have. Main thing is it's pumping water. It's supposed to be pumping water. That's a closed loop because it's continuing to go through the boiler and then back. I had a heat pump in a walk-in freezer. We cranked the temperature down to 20 degrees below zero in dead airspace. Now imagine this, if you got any background in refrigeration, we're in dead airspace, the temperature's 20 below zero. We did it every single Saturday for an entire year. People from all over the world came to see it. We said, bring your own test equipment, take the thing apart if you want to. We had a $10,000 challenge to find any gimmick or anything in it. And every single weekend, we cranked the temperature down to 20 below in dead airspace, and we made water hot enough to burn your hand from energy we took out of that box at 20 below at a 2-to-1 COP. Same average performance of the GE heat pump in America. Only it's 20 below in dead airspace. And we challenged all the heat pump manufacturers to come anytime you want to, either find a hoax with us or bring your unit down and see if you can do that. Nobody ever came. A lot of customers came, lots of people from all over the world came, Pakistan, everywhere. So anyway, we're in here testing this every year, every weekend for a year. And a man came to the show one day, and what a guy this was. Now, we're trying to build this thing. It's going to take 2 years and $2 million, and I'm raising capital selling heat pump things to get the money. And a guy walks in, and he comes up to me at the end of the show, and he says, Mr. Lee, I am absolutely astonished. I want to shake your hand, and I want to tell you, I have no doubt you have got the best heating system in the world. Yours tops everything out there from solar all the way down the line. You did it. But you need to know me. You know why you need to know me? Because I have built the world's most efficient heat engine, and you have got the world's most efficient heat source. He says, if we got together with our two technologies, we could become the most dangerous men in the world. I thought, wow, I've never been the most dangerous man in the world. I've kind of wanted to be. And so, you see, this man's name was Dr. Fisher. Now, this guy proved that they built the steam engine wrong. I had the pleasure of building his unit in my research lab, and we took his great big unit, because why wouldn't I want a great big one? I don't want to put everybody on the grid system with a new system that can exploit them some more with all the arrogance that comes with it. I wanted to give people the opportunity to be totally independent of the grid system. Remember, that was my goal. So we took the big one we had and we scaled it down into a model not much, a little bit smaller than this one. It was a little smaller than this. It was about that long. It's about 13 inches long, 6 inches in diameter. And that one was going to be big enough to be able to power all the energy you needed for your house, and so I didn't want one bigger than that. And by the way, that little unit could fit in the glove compartment of any American-made car. I went across the United States of America telling my story. I told it in every state of the United States, and I got 1,000 people to join me telling my story. We put a media ad campaign together because the media wouldn't cover it, so we ran commercials. And we did a 60-second commercial cutting a power line and saying you can power your house with no electricity, external electricity, run your car with a new engine that runs with no gasoline. We did a 60-second commercial nationwide. As far as we can tell, about 10 million people saw it. And after that happened, that was too much. That couldn't be tolerated. And so I got a letter from the state of California inviting me to come back to California to go to court. So I flew back from New Jersey to California to go to court, and when I walked into the court, the judge said, "You're probably wondering why you're here," and I said, "Yes, I am." And he said, "Well, because I've been ordered by the state of California to put you in prison." And I said, "Well, that's really interesting. You're putting me in prison, but I've never been convicted of the crime. How do I go to prison without a trial and without being convicted?" And I said, "You can't do that, can you?" And he said, "Well," he says, "I've been ordered by the state of California to put you in prison, so that's where you're going, but sounds like you got a hell of a case for appeal." That, by the way, is a quote, and I do have the transcript. I walked out of prison 2 years ago, and now we have rebuilt our whole national network of distribution of distributors. We're in every state of the United States. We're in every major county of the United States. We have people now who understand exactly how the government works, exactly how the big boys work, exactly how the energy companies work. And we've got it all figured out, and we've got far, far, far more technology than we ever had in 1987. We got a lot more money than we ever had in 1987, and we're about to rock your world.
Well-respected scientists like Shinichi Seki and Sehuji Inomata are receiving substantial government and industry support.
To understand this machine, you need, mind change, paradigm shift in yourself, So far, physics, ordinary science, consider only material world. But we should think another world, as an unseen world. And we should recognize that unseen world and material world is connected. This energy comes from the other dimension.